Do you recall the very first instance you managed to capture one? It was a balmy summer evening, still illuminated enough to clearly distinguish the grass, yet dusky enough for the initial twinkling sparks to emerge. You'd dart across the lawn, a glass container in hand, tracking those intermittent flashes, attempting to anticipate their next reappearance. Perhaps you managed to gather a small cluster, holding the jar close to your face, mesmerized by their gentle luminescence within your grasp. This particular recollection is a shared experience among nearly everyone who spent their formative years in the eastern United States, and for a great number of people, it stands as one of their most distinct and vibrant childhood memories. However, there's a significant detail that almost none of these children were ever privy to. Those glowing signals were not arbitrary occurrences. They weren't merely for aesthetic appeal. Every solitary flash that you pursued across that expanse of lawn was a carefully orchestrated communication, precise, encoded, and designated for a particular recipient, with the firefly transmitting it patiently awaiting the exact, appropriate response. Tonight, our objective is to decipher that very message. We will delve into the actual phenomena occurring within the illuminated spectacle above your garden, as well as what transpires in the surrounding darkness beneath it. And by the conclusion of our discussion, I believe your perception of those summer evenings will be fundamentally altered. Let us commence with the light itself. The luminescence of a firefly is generated through a biochemical process within a specialized organ located in its abdomen. An element known as luciferase engages with a compound called luciferin in the presence of oxygen and a molecule termed ATP, the identical energy currency that energizes every cell in all living organisms, culminating in the production of light. This is cold light, a radiant emission that generates virtually no heat, boasting an energy efficiency of approximately 96%. To provide some context, a conventional incandescent light bulb converts a mere 5% of its energy into visible light, expending the remainder as heat. The firefly, on the other hand, converts 96%. By any engineering benchmark, it represents one of the most efficient light-producing mechanisms ever subjected to scientific scrutiny, and indeed, researchers have taken note. The enzyme luciferase, painstakingly extracted and synthesized from firefly biology, is now a paramount tool in contemporary medical and biological research. Healthcare facilities utilize luciferase-based assays to swiftly identify bacterial contamination in blood and urine samples. Pharmaceutical scientists employ it to investigate the behavior of cancerous cells and their responses to therapeutic interventions. Even the National Aeronautics and Space Administration has explored the potential application of firefly compounds for the detection of life signatures in extraterrestrial environments. The very glow you observed from your backyard as a child is, in essence, the same biological apparatus that currently aids physicians in diagnosing infections more rapidly and assists researchers in studying diseases at a microscopic level. However, this radiant display was never intended for any of those purposes. Its original design was for something far more rudimentary and considerably more pressing. Its sole intention was to facilitate the finding of a mate. Each distinct species of firefly possesses its own unique flashing sequence. This involves a specific configuration of flash duration, the interval between flashes, color, and the trajectory of its flight, all of which are exclusive to that particular species. The males emit flashes while in flight, thereby announcing their presence and signaling their desirability. The females of the same species remain stationary within the surrounding vegetation, observing intently. Upon recognizing a male whose flashing pattern aligns with her species designation, she reciprocates, but only after a precisely calculated delay. The time elapsed between the male's illumination and her response is itself an integral component of the communication code. The male interprets this temporal gap, modifies his flight path, and navigates towards her, guided by this dialogue. It is a discourse conducted entirely through light, and this intricate exchange occurs concurrently across every open field and garden periphery where fireflies are present on a summer evening, comprising hundreds or even thousands of individual conversations, with each pair employing a private frequency that renders it distinct from all others. This explains why disparate firefly species can coexist in the same field on the same night without any interference. Each species broadcasts on a unique channel and listens exclusively for its corresponding signal in return. The accuracy of this system is truly astounding. Investigations into firefly communication have revealed that females can differentiate their species' flash pattern from a closely similar one with a temporal discrepancy of less than half a second. The level of recognition is this exact, and the male's capacity to pinpoint a female based on her singular answering flash, sometimes from distances of 20 to 30 feet in absolute darkness, hinges on the perfect maintenance of this precision by both participants. Your garden on a July evening is alive with a communicative network of extraordinary complexity, one that necessitates no external infrastructure, no power source beyond the firefly's inherent biology, and no ongoing upkeep of any kind. Now, let us turn our attention to the more clandestine aspect of this network, as not every illuminated entity in your vicinity is conveying an authentic signal. Within the eastern United States, there exists a particular group of firefly species belonging to the genus Photurus, which has developed one of the most remarkable and unsettling survival strategies observed in the insect kingdom. The females of these species do not limit their interactions to males of their own kind. They actively monitor the communications of other species and then deliberately respond. A female Photurus, positioned within the vegetation, detects the flashing pattern of a male belonging to a completely different firefly species, a Photinus male, for instance, who is actively searching for a female of his own species. She then waits for the precise time interval that a Photinus female would typically employ to reply. Following this anticipation, she emits her own flash. The Photinus male, perceiving what appears to be an ideal response from a female of his species, adjusts his aerial course and descends towards the source of the signal. However, he is not approaching a prospective mate. Rather, he is flying directly into an expertly laid trap. The female Photurus then apprehends and consumes him. This act transcends simple predation for sustenance. Research published in the esteemed Proceedings of the National Academy of Sciences has documented that by consuming Photinus males, the female Photurus assimilates defensive chemical compounds, known as lucibufagins, which are present in the Photinus species biology, but which Photurus itself is incapable of producing. These compounds render her toxic to potential predators, including birds, spiders, and other insects that would otherwise prey upon her. She is not merely obtaining a meal, she is acquiring a chemical defense mechanism. She expertly mimics the signal. She lures her unsuspecting prey. She absorbs its protective compounds, effectively appropriating them as her own. It is a masterful display of predation, deception, and chemical warfare, all orchestrated through mere flashes of light on a summer night. This peculiar behavior was first formally identified by entomologist James Lloyd of the University of Florida in the 1960s, who coined the evocative term femme fatale fireflies, a designation that has endured within scientific literature ever since. Certain individual Photurus females have been observed to expertly replicate the flashing responses of as many as 4 different Photinus species, dynamically shifting between these mimicries based on the presence of particular male species in their vicinity on any given night. The luminous spectacle above your garden is far more complex and deceptive than it initially appears. Now, let us shift our focus from the sky to the earth below. For while the adult fireflies are engaged in aerial communication, an entirely different drama unfolds within the soil beneath. Firefly larvae are formidable terrestrial predators. They inhabit the leaf litter, the soft earth, and dwell beneath logs and bark, actively hunting slugs and snails in the nocturnal darkness. They are equipped with hollow, curved mandibles, functionally akin to those of an antlion, which inject digestive enzymes into their prey, enabling them to feed in a manner that is remarkably efficient for their diminutive size. A single firefly larva is capable of consuming multiple slugs over the course of a single season. This has direct implications for your garden. Slugs are among the most destructive, soft-bodied pests in any cultivated area, feeding voraciously on seedlings, leafy vegetables, and the root systems of flowering plants, primarily during the nighttime hours when they are difficult to detect and control. While chemical methods for slug eradication can be effective, they carry inherent risks for soil microorganisms, avian life, and other forms of wildlife. Conversely, firefly larvae pursue slugs precisely within the preferred habitat of these gastropods, damp soil and leaf litter, and do so entirely without introducing any such environmental risks. A garden that hosts fireflies overhead consequently benefits from the presence of firefly larvae below, performing essential ecological work within your soil that you would otherwise need to undertake yourself. However, there is a crucial aspect of this narrative that introduces a somber note. Firefly populations across North America are experiencing a quantifiable decline. The contributing factors are well documented. Light pollution significantly disrupts the synchronized flashing communications upon which fireflies depend for successful reproduction. Artificial illumination renders it increasingly difficult for males and females to locate one another, and in areas with excessive artificial lighting, firefly populations dwindle rapidly. The application of pesticides is lethal to both adult fireflies and their developing larvae. Furthermore, the destruction of the undisturbed, damp habitats essential for larval development, such as wet meadows, the edges of woodlands, and gardens with adequate leaf litter and moisture, eliminates the crucial breeding grounds that sustain populations from one year to the next. The consequence of these factors is that many individuals who fondly recall abundant summer firefly displays from their youth are now witnessing significantly fewer than they remember. This is not a matter of nostalgic idealization of the past. Scientific studies meticulously tracking firefly populations over extended periods have confirmed genuine and substantial reductions in their abundance across numerous regions of the country. The yard you knew in your youth harbored a greater number of fireflies than the yard you inhabit today. And this disparity is likely to continue widening unless the ecological conditions essential for firefly survival are actively preserved. This leads us to consider what practical actions you can take, and it begins, as is often the case within the context of a garden, with the principle of doing less rather than more. Minimize outdoor illumination during summer evenings, particularly in areas where you have observed fireflies. A single, intensely bright light left on throughout the night can suppress firefly activity over a considerable radius. The utilization of motion-activated lights, amber-colored bulbs, and lights strategically positioned away from open garden spaces can all mitigate the impact on firefly communication without plunging your surroundings into complete darkness. Throughout the season, refrain from disturbing leaf litter and ground cover, especially in the moist, shaded sections of your yard. This constitutes the habitat where the larvae reside. Its removal, whether through blowing it away or replacing it with synthetic landscaping materials, eradicates the vital layer of the garden where firefly reproduction actually takes place. Cease or significantly reduce the use of pesticides within and around areas where fireflies are active. Broad-spectrum insecticides indiscriminately target not only the intended pests, but also the firefly larvae that are diligently hunting slugs in the same soil. Furthermore, cultivate native vegetation, with a particular emphasis on grasses and flowering plants that establish the open yet sheltered structure preferred by adult fireflies for their nocturnal flights. The fireflies that still grace your garden do so because certain aspects of your environment remain conducive to their survival. The moisture levels are appropriate. The ambient darkness is sufficient. The habitat is intact enough to support a larva through the soil and an adult through the air. This is not a guaranteed state of affairs. It is the outcome of conditions that can vanish swiftly and only gradually be restored. If you observed fireflies this past summer, even a small number, even for a brief period, your garden continues to be connected to something that is becoming genuinely scarce. And that connection is undeniably worth protecting. And if today marks the day you chose to extinguish your porch light and simply observe, then something fundamental has just shifted in the way you perceive your summer nights. That shift is precisely the foundation upon which this community is built. I will see you in the next installment.